Today we are going to start a new playlist of my channel, and this is actually regarding the statistical mechanics or statistical physics. In fact, after a huge demand of the viewers of my video, it was long awaited that we should start a playlist of statistical physics, because several of you have demanded several times that we should start the concept of statistical mechanics as soon as possible. And as I have told you that we will start the course on statistical physics, so today I am going to start that very chapter, that is statistical mechanics. Actually, you will see that this course will be designed in such a manner that it will cover the syllabus of both BSc students of almost all Indian universities, MSc students of almost all Indian universities, and apart from that, the course will also provide materials for the preparation of UGC CSR NET examination, UPSC Civil Services Physics Optional Examination, and different Public Service Commission examinations, IIT JAM examinations, and several competitive examinations. Okay. So, in fact, in this first lecture on statistical mechanics, we will see something regarding about the statistical mechanics, that is, what is this statistical mechanics, and mainly we will focus that what we will actually are going to discuss in this statistical mechanics in our forthcoming videos. Okay. So just add it is a new topic for your playlist. So I would like to first of all define what is this statistical mechanics. Okay. In fact, this statistical mechanics is defined as a scheme of a study of the macroscopic properties of system in terms of their microscopic properties. When you say that statistical mechanics is a scheme of a study of macroscopic properties in terms of microscopic properties, what does it mean? You know, what are the macroscopic properties? You know, in fact, macro means bulk, that is something large. And when you say macroscopic properties of a system, that means the properties which are defined for the system as a whole. That is, macroscopic properties are such properties which is not defined for a point, but it is defined for a system as a whole, or you can say that these properties are defined for bulk of the system. For example, you can say that the pressure P, volume V, and temperature T, these are the important macroscopic properties of a thermodynamical system. When you say pressure, you don't define pressure at a particular point, but you always define pressure of a gas, pressure of a fluid, atmospheric pressure. Okay. So pressure is not defined at a particular point, but pressure is defined for a given system. So this is a macroscopic property of the system. Similarly, when you talk about temperature, you know, you can say that temperature of boiling water, temperature of a particular place like Patna, like New York City. Okay. But you never say that the temperature of a particular point situated in Patna is so and so that. You never say that. So this temperature is also defined for a system as a whole, and so it is also a macroscopic property. Okay. On the other hand, when you talk about the microscopic properties of a system, that means the properties which are defined for a point, or which are defined at molecular level, atomic level, microscopic level. Okay. For example, when you say energy, speed, these are microscopic properties. Why? Because we define energy of a particle, energy of a molecule, energy of an atom, energy of electron, energy of proton. So energy is defined for a particular particle or for a particular point, and similarly you talk about the speed of nth particle, speed of ith particle. So these are the microscopic properties. In statistical mechanics, we deal with the macroscopic property of a system like its pressure, volume, temperature, etc. But these properties will be discussed on microscopic level. That is, these are described in terms of the microscopic properties of the system. Okay? But when you say statistical mechanics, why the word mechanics here? Because this mechanics word is due to the fact that this deals with the mechanical system. Okay? In statistical physics, we deal with the mechanical system, and so the word mechanics is used. Okay? It means that in the study of statistical physics, we always talk about the mechanical system. Okay? And why this word is statistical? You know, whenever you use the statistics, that means the calculation is not very precise, not very exact, but we always talk in terms of the probable value or the average value or the mean value. So in case of the study of statistical physics, we always talk about the imprecise or statistical prediction, never the exact calculation, but we always take the statistical value or the average or mean value or the probable value. So in this sense, this physics is called statistical physics. Okay? So I hope you have understand what is this statistical mechanics. I am just repeating the same fact that statistical mechanics you have defined that it is just a scheme of a study of macroscopic properties of a system in terms of its microscopic properties. And this is called mechanics because it deals with the mechanical system, and it is statistical because it makes only imprecise or statistical prediction. Okay? Now, as you know that the mechanical system is also dealt in the classical mechanics and also in the quantum mechanics. So why there is a need to study the mechanical system of this statistical mechanics? Is this classical mechanics not sufficient to deal with the mechanical system? What is the drawback of the classical mechanics due to which we need the concept of statistical mechanics? We will see. As you know, when you talk about the classical approach of solving a mechanical problem, actually there are two very important famous classical approach to solve the mechanical problem. One of them is called Lagrangian formulation of classical mechanics, and another is called Hamiltonian formulation. Okay? And you know, whenever we have to deal with a mechanical system, then first of all, in any approach, either in Lagrangian approach or in Hamiltonian approach, first of all, we construct the equations of motion for the given system. Okay? Our first step to solve a mechanical problem is what? First of all, we set up or we construct the equations of motion for the given mechanical system. And once you set up the equation of motion, the next step is to solve those equations of motion. And after solving the equations of motion, we get all the informations regarding the mechanical system. Okay? When you are going to solve the mechanical problem by Lagrangian approach, then you write the Lagrange equation of motion. You know that the Lagrange equations of motion are given like this. This is d dt del L by del Qk dot minus del L by del Qk equal to 0. Actually here you know that this Qk are generalized coordinates, and what are these Qk dot? You know these are generalized velocities, you know it, okay? And if f is the degree of freedom of this system, then this subscript k means 1, 2, 3, so on f. So this equation of Lagrange defined in equation A does not represent only one equation. But if f is the degree of freedom of our system, then actually these are f equations of motion, not only one equation. Okay? There will be f equations of motion, and all these equations are of first degree and second order differential equation. Okay? But there is another mathematical approach to solve the mechanical problem, and that is called Hamiltonian approach. And you know that in case of Hamiltonian approach, we set up the equation of motion which are called Hamilton's canonical equations of motion. And these equations of motions are given like this. This is Qk dot equal to del H by del Pk, and Pk dot equal to minus del H by del Qk. Here also this k is 1, 2, 3 and so on up to f. Okay? These are called Hamilton's canonical equations of motion. And here, as you can see, the number of equations, if written in Hamiltonian form, will be actually of 2f. 2f will be the number of equations. In Lagrange, number of Lagrange equation will be f if degree of freedom is f. But if degree of freedom is f, then number of Hamilton's equations will be 2f. But now think, if the degree of freedom f of this system is very large, or in other words you can say if you are talking about a system containing the large number of particles, or you are talking about the many body problem. In fact, in case of many body problem or a system consisting of large number of particles, this degree of freedom f will have a very large value. And if f is very large, you can see that the number of equations of motion will be also very large. Okay? And if the number of equations of motion will be very large when the degree of freedom is very large, then its solution becomes almost impracticable. In practice, you can't solve the equations of motion if its number is very large, because there will be a lack of informations. In case of large degree of freedom, there will be a lackness of informations in the physical problem, and due to that lackness of information, or you can say that due to the incomplete information defined in the problem, we will be unable in practice to solve the equations of motion. So particularly in case of many body problem, these approaches of classical mechanics, that is Lagrangian approach and Hamiltonian approach, will be not sufficient, will be not appropriate to deal with the physical problem. Okay? Actually, what will happen then? How the physics of such many body problem will be solved? Actually, in that condition, the statistical mechanics or statistical approach is the best approach for solving such a problem of many body. Okay? So you can say that the statistical mechanics is the most suitable candidate or most suitable agent to deal with the problem of many body system. Okay? Many body system. So how, when this statistical physics is needed and how it is superior than the classical approach, and how classical approach fails and this statistical approach then works, you have learned. Okay? Actually, the statistical mechanics and the thermodynamics, these are very two close branches of physics. Okay? In fact, statistical mechanics and thermodynamics, it appears that they are not different, but the approaches of thermodynamics and statistical mechanics are different. We study the same system both in thermodynamics and statistical physics, but the approach to study the same system in case of thermodynamics and statistical physics are actually different. Okay? So it is very important to understand the difference between the statistical mechanics and the thermodynamics. Okay? It is very important. Actually, you know that both of them deal with the same field or the same problem. But you know that thermodynamics is based on some basic postulates, and those basic postulates on which thermodynamics is based are actually called the laws of thermodynamics. They are called laws of thermodynamics. And you have definitely studied the laws of thermodynamics, that is zeroth law of thermodynamics, first law of thermodynamics, second law of thermodynamics, third law of thermodynamics. You have studied. So every system in thermodynamics is described in terms of these laws of thermodynamics, which are actually the postulates. Okay? So you can say that the study of thermodynamics has no molecular basis. It does not deal with the problem on atomic or molecular level or microscopic level. But the same problem, when dealt in terms of the statistical mechanics, we see that the description is on the basis of molecular theory. It provides actually a molecular theory or atomic or particle theory or the microscopic theory to deal with the same problem. So you can say that this statistical mechanics gives us more far insight into the problem with comparison to the thermodynamics. Okay? So we can say that it is statistical mechanics that provides a molecular theory of thermodynamic properties of a macroscopic system. So you can say that the statistical mechanics connects mechanics with thermodynamics, or in other words, you can say that it bridges the gap between the mechanics and the thermodynamics. Okay? Mechanics and the thermodynamics. Actually, when you talk about the statistical mechanics, always in this statistical mechanics, we talk about the probable value. Actually, the probability theory is a very strong mathematical tool to deal with the statistical physics, because only a statistical or probabilistic consideration can yield a theory which predicts macroscopic properties from an atomic model of the system. Okay? And you should also note that it is important that the statistical mechanics is concerned with the relationship between the macroscopically measurable parameters and the microscopic parameters. Okay? So these were some of the important facts regarding the statistical mechanics before the study of the proper chapter. Now, in fact, statistical mechanics may be broadly divided actually in two parts. The first part is called theory of equilibrium state. You can see theory of equilibrium state, and the second part is called theory of non-equilibrium state. Okay? Actually, when you say theory of equilibrium state, in fact, in this theory of equilibrium state, we deal with the situation in which the probabilities and the average values are independent of time. Okay? However, in case of theory of non-equilibrium state, you will see that in this theory, we need to consider the probabilities and average values depending on time, not independent of time. Okay? So actually, this helps us to understand the process through which a physical system initially in a non-equilibrium state approaches a state of equilibrium in course of time. Okay? But we further divide the statistical physics or statistical mechanics again in two categories, and those two categories are called classical statistical mechanics, or it is also called Maxwell-Boltzmann statistics, and another is quantum statistical mechanics. Or in fact, in this quantum statistical mechanics you will study, there will be two statistics. First quantum statistics is called Bose-Einstein statistics, and the second one is called Fermi-Dirac statistics. Actually, when you say that there are two types of statistical mechanics, that is classical and quantum, actually these classifications depend on the character of the constituent particle, such as atoms and molecules of the system. Actually, you know, when the atoms and molecules constituting the system are governed by the laws of classical mechanics, the corresponding statistical mechanics is then called classical statistical mechanics. But on the other hand, if the particles of the system are governed by the quantum mechanical laws, not by the classical laws, then such statistical mechanics are called quantum statistical mechanics. We will see that actually the particles which are governed by the laws of quantum mechanics are of two types. You know that first one is called bosons, and these bosons are the particles having either the zero spin or the integral spin in units of h bar. So it has the spins of 0, or you can say h bar, 2h bar, and so on. Or you also say that the bosons are the particles having the symmetric wave function. Okay? And these particles do not obey the Pauli's exclusion principle. So the particles having these properties are called bosons, and they are studied by the help of Bose-Einstein statistics. Okay? Again, on the other hand, you know that there are a group of particles which are called fermions, and these fermions are particles having half integral spins. That is, their spins may be half h bar, 3 over 2 h bar, 5 over 2 h bar, and so on. These particles actually obey the Pauli's exclusion principle, and they have anti-symmetric wave function. Okay? And such particles are governed by the quantum mechanical laws of Fermi-Dirac statistics. So, on the basis of nature of particles governed by the quantum statistics, this quantum statistical mechanics has been further classified into two classes: Bose-Einstein statistics and Fermi-Dirac statistics. Okay? So, I hope you have understand this basic idea of the statistical mechanics. But now I am just going to inform you that if you will ask that the course which I will provide in this series of in this lecture series on statistical mechanics of my playlist, that course will be useful for whom? The course which I will provide you is meant for whom? I am just going to deal with. As I have told you earlier, that the course which I am going to provide you in this playlist of statistical mechanics, that will be very useful for the students preparing for the undergraduate examinations of different Indian universities, and also the course will cover the syllabus of the postgraduate level of almost all Indian universities. Okay. At the same time, this course will be also very useful for the students preparing for different competitive examinations by taking physics as an optional subject. Okay. And at the same time, this course is also useful for the students of chemistry, because in chemistry, in physical chemistry, you have to study statistical mechanics. So this course is not useful only for the students of physics, but it is also useful for the students of chemistry. Okay, for different competitive examinations like UGC CSR NET examination. If you are going to take physics as an optional subject in the UPSC civil services examination or the different state public service commission examination, then this course will be very useful to you. You can see that statistical physics and thermodynamics is a very important topic of the syllabus of the UPSC physics optional. So this course will be also very helpful for the candidates who are preparing for the UPSC civil services by taking physics as an optional subject. Okay. Now nowadays you know that apart from the UGC CSR NET examination, different universities of India actually provide examination for the students for which is called pre-PhD test. Okay, pre-PhD test, and after competing in such examination, the students get enrolled in the PhD course, and for that the student has to select his optional paper. So if you are a student of physics and you are going to appear in the examination like pre-PhD test of any university of Bihar, then you should watch the videos provided in this playlist, and that will be actually very useful for you. Okay. Now, what actually we are going to deal in this playlist of statistical mechanics? I am just giving a brief account of the course material which we will deal in the forthcoming lectures or forthcoming videos. Actually, the first chapter which this playlist will contain is actually the basic principle of statistical mechanics. When you say basic principle of statistical mechanics, we will provide a large number of videos on this. Actually, we will see the concept of phase space, the concept of macroscopic and microscopic states. We will also see a very important theorem which is called Liouville's theorem. Okay. Apart from that, we will study the concept of density matrix, okay, and equilibrium in statistical physics. The different such type of ideas will be actually discussed in this basic principle of statistical mechanics. Then our second chapter will be ensemble theory. This is actually a very important chapter, and it is almost in the syllabus of almost all universities of India in the course of statistical mechanics or any competitive examination. Actually, when you talk about the ensemble theory, we will deal with in detail by our videos the three ensemble theory, and those are microcanonical ensemble, canonical ensemble, and grand canonical ensemble. All these three ensemble will be dealt in very detail in our forthcoming videos. Okay. After this ensemble theory, we will focus or we will provide videos on theory of ideal classical gases. When you say theory of ideal classical gases, it means you are talking about the classical statistical mechanics, which is also known as Maxwell-Boltzmann statistics. So actually in this theory of ideal gases, we will see the concept of the ideal gases in microcanonical ensemble. Okay, we will also see the concept of entropy. We will study a very famous paradox that is called Gibbs paradox in this chapter, and many more. Okay. And after that, we will study the quantum statistics, and this is most important chapter. And in this quantum statistics, as you have seen, there will be actually two quantum statistics, Bose-Einstein statistics and Fermi-Dirac statistics. So we will deal with the ideal Bose system and the ideal Fermi system. Okay. When you see the concept of ideal Bose system, we will deal with some very important phenomena like Bose-Einstein condensation. We will also see the concept of black body radiation or the photon gas. We will also see the concept of device model of solids or device theory or Landau theory of helium second. These will be some of the important videos which we will deal in the ideal Bose system. And after that, we will provide videos on ideal Fermi system, and in this ideal Fermi system, we will see from the basic concept, apart from the basic concept, we will also deal with the magnetic properties of the electron gas or magnetic behavior of the electron gas, in which we will see the polyparamagnetism, Landau diamagnetism, and so on. Okay? And after that, our video will be on phase transition and critical phenomena. Phase transition and critical phenomena. This is also a very important chapter. Apart from the videos on the first order phase transition, we will also provide the videos on second order phase transition, in which we will deal with so many important concepts. Okay? And after that, our videos will be on dynamical theory of gases. This is also a very important chapter. In fact, in this chapter, we will deal with Brownian motion, the Langevin theory, okay, the Fokker-Planck equation. These are some of the advanced theory of this statistical mechanics. And finally, we will deal with a very advanced chapter, and that will be on non-equilibrium processes. Because I have told you that actually broadly this statistical physics is of two types, the theory of equilibrium state and the theory of non-equilibrium state. So actually in this non-equilibrium processes we will deal with the theory of non-equilibrium states, and this is a very important chapter. And after completion of all these chapters in this playlist, I hope we will be able to face any examination in your career taking physics as an optional subject, in which statistical physics is an important chapter to study you. Okay? So I hope you have learned something in this introductory lecture, although this was just an introduction to my new playlist on statistical mechanics. And so I hope you will enjoy the videos on the classical statistical mechanics in the forthcoming lecture, and I hope you will love the videos like my previous videos. Okay, so thank you very much.